Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Well, if you're not familiar with our channel, we cover technical topics related to automation, very often geared around the Horner automation line of all-in-one controllers. An all-in-one controller is a component that combines the functionality of a PLC with a built-in HMI. But we also cover topics that are just general industry topics, and today is one of those. Let's take a look. How does IO-Link work? And anytime you're watching one of our live streams, if you're watching it live, you can give us your questions in the chat section. We've always got folks standing by. And if you're watching on replay, give us those comments and questions in the comment section, and you'll find we get back to you very quickly. Okay, so today is an industry standard topic on IO-Link. Let's just dive right in and take a look at how we're breaking down today's topic. All right, we're going to start with, what is IO-Link? What problems does it solve? How does it work? What are the benefits? Why are we using it to begin with? And then at the very end, we will talk about the IO-Link products that are available from Horner Automation. All right, let's dive right in. So, what is IO-Link? Now, IO-Link is the first standardized technology worldwide for communication with sensors and actuators. Now, it's based on an established 3-wire connection that we traditionally use with our sensors and actuators these days, and it doesn't have any special cabling requirements. That's a big advantage. Now, it's a point-to-point communication scheme. It's not a Fieldbus. We'll talk about that in a minute. And it's used predominantly in industrial applications. You typically don't find it in residential applications or light commercial applications. So it's primarily an industrial standard. Now, what problems does IO-Link solve? Why do we even want it? I mean, we know how to interface with sensors and actuators. What's so special about IO-Link? Well, if we think about how sensors and actuators have evolved and have developed, especially over the last 10 or 15 years, they're way more sophisticated than they have been in the past. Many more sensors and actuators contain microprocessors that can handle more than just the basic measurement or the basic job that they're performing. And they often required a fairly sophisticated setup process to adapt that specific sensor or actuator to your application. Now, of course, this isn't true with some very basic sensors and actuators, but there's more and more smart devices out there that do have these characteristics. Now, when we're talking about some fairly sophisticated sensors and actuators, and we want to interface those with our traditional digital I/O and analog I/O, there are some limitations. There are limitations in the amount of data that can be shared over that interface, the accuracy or resolution of the data that's shared over the traditional I/O interface, and any kind of sensor or actuator setup is always handled completely outside of that digital or analog I/O interface. So those are some definite limitations. Now, let's take a look at our traditional I/O interface. So we're not talking IO-Link right now, we're talking the traditional I/O interface. Now, for a digital sensor, maybe something like a photo eye, all right, it's going to have some sort of voltage output that we're going to connect to an input of a PLC that's going to be either off or on to reflect the status of that sensor. For a digital output, similarly, we're going to have a voltage that's going to be switched on and off by the PLC to turn that actuator on and off, say a solenoid valve. When we go to the analog world and we've got an analog sensor, let's say a level sensor or a distance sensor, that sensor, let's say, is measuring water height or something in a tank, right? And its output of that sensor is going to be sent to the PLC in the form of an analog output, let's say 0 to 10 volts. So the voltage that is being sent specifically by the sensor will be proportional to the level of water in the tank, for instance. And then for an analog actuator, let's say a proportional valve that can open between 0 and 100%, our PLC is going to be sending a voltage signal, as an example, an analog voltage signal that varies from 0 to 10 volts based on how open or closed they want that analog valve to be, for instance. So 0 to 100% might represent 0 to 10 volts. All right, and of course, that's really the world we live in for a majority of our I/O these days. Now let's talk about those limitations that we're living under in our traditional I/O world. The amount of data we're able to share is limited, either a single bit or a single analog signal. The accuracy of the data we're sharing, if we're talking analog, that's limited because we've got to do analog to digital conversion or digital to analog conversion, which is prone to errors potentially, or inaccuracies at least, and is also limited by the resolution of the analog input or analog output card in our PLC. And again, as I mentioned before, there's nothing in these signals here that has anything to do with setup. So any setup that we need to do on the sensor or the actuator has to be handled completely separately as a totally separate process. Okay, now let's talk about IO-Link. How does it work? Now, one of the beauties of IO-Link is it does build on established I/O wiring practices. Now, if you looked at, let's say, the modular wiring, let's say in an M12 connector for a typical sensor or actuator, those are typically available with either a 3-pin, a 4-pin, or a 5-pin type configuration. But let's say we're going to take a look at a typical 4-pin modular pinout for a sensor or an actuator. We very well might be looking at this kind of standard pinout, all right, where we have 2 pins that are allocated for power, plus and minus, and then we have 1 pin for the I/O signal, either the input or the output, and we might, in the case of a 4-pin pinout, actually have 2 I/O pins available, depending on the sensor involved. But more than likely, only one of those 2 pins would be active. Now, when we take a look at IO-Link, this pinout looks very similar, all right? So it builds on that established approach. The only real difference you'll find is that pin 4 is now a special pin, the communications pin. And it's not just on steadily or off steadily, it's actually controlled in an on-off fashion so that digital communications can be handled and messaging can be provided through that port. So it's an in/out port that can do messaging on pin 4. That allows you to do much more sophisticated and less limiting communications. Now, again, is IO-Link another Fieldbus? No, IO-Link is not a Fieldbus. If we think of Fieldbuses like Profibus, for instance, they're typically multi-drop, right? That's the architecture that you're typically seeing with a Fieldbus. And even the Ethernet-based Fieldbuses, even though we all know that those are wired to switches and those sorts of things, those still, from a architecture standpoint, are more analogous to multi-drop. IO-Link is a point-to-point communication, all right? And because it has limitations in distance and baud and those sorts of things that we'll talk about in a minute, it's very often used alongside a Fieldbus, not in place of a Fieldbus. Now, why would you need IO-Link at all? If you could use a Fieldbus to solve a lot of these same issues that we're solving with IO-Link, well, Fieldbus devices, whether they're sensors or actuators, can be pretty expensive because most Fieldbuses require a fairly sophisticated chip to perform the communications, whereas IO-Link is much simpler. The chip that's required to do the IO-Link communications is much less advanced, and therefore the circuitry is less expensive, so IO-Link sensors are typically much less expensive than a Fieldbus sensor of the same type. Now, let's talk about the components of an IO-Link system. Let's talk, first of all, you're going to need what's called an IO-Link master. What does the IO-Link master do? Well, that's the component in kind of the center of the diagram. We're kind of showing a version of an IO-Link master that might look like one of those IP67 or IP69K type blocks or bricks. All right, but anyway, whatever the form, whether it's DIN rail mounted or IP69K or plugs into a PLC directly, the IO-Link master is going to perform several functions. First of all, it's going to act as the gateway between the PLC or the Fieldbus so that all the data between the sensors and actuators can be exchanged with the PLC. All right. Of course, it's going to handle all the communications with the sensors and the actuators. And it also has the capability to store the configuration for each sensor or each actuator that's connected to, It has the ability to store that configuration in its local memory. You'll see why that's important in a minute. Now, also needed is IO-Link configuration software. Remember, IO-Link devices are sophisticated. They need configuration. So you're going to need this software to set up each of the devices. And the configuration may just be in the form of a PC running software and connecting to the IO-Link master or the IO-Link devices, maybe through some sort of, maybe a USB adapter of some sort. All right. Now, the other thing you need to go along with your software is you need IODD files from the device manufacturers, because there are hundreds or thousands of different IO-Link sensors and actuators available, and each one has some specific parameters or information that needs to be gathered, and that is stored in the form of an IODD file. Okay, let's talk about some of the details of the communication. Again, IO-Link does not use any kind of special cabling. That point-to-point link between the master and the sensors or actuators is all just standard cabling, sensor actuator cabling, up to 20 meters long. The baud rates range from 4,800 baud up to 230 baud. Cycle times are typically around 2 milliseconds between the master and the devices. And then there are multiple messaging types. Now, we're not going to go into the framing and all the detail on the messaging types, but we are going to summarize them here. You've got cyclic data, which is the process data or real-time data that's exchanged, again, at runtime, anywhere from 0 to 32 bytes. You've got acyclic data, which is typically your parameter or setup information. And then there also can be acyclic events, things like errors, warnings, and notifications. Now, if you're going to be setting up an IO-Link system, here's the basic process. You're going to need to configure all of your IO-Link devices, all right? So maybe you're going to be connecting your computer directly to the sensors or actuators for some of those devices. Maybe you're going to be wiring everything up to the master and doing all the configuration using your software through the master. So your case may vary. Again, you're going to need the IODD files for each of the devices you're using, all right, with all the device-specific information in there. You're going to be setting up each device individually, getting its parameters just the way you want it, and storing those parameters in the device itself. And then, more than likely, you're going to want to store those parameters also in the master. So if a master is connected to 3 different devices, you're going to want to have those device configurations stored not only in the individual devices, but also in the master as a whole. Okay, so now let's talk benefits. What are the benefits? Well, let's talk about the advantages of the data we're getting back from our sensors or the data that we're sending to our actuators. If we had, let's say, a distance sensor, a laser distance sensor, if we were using a traditional analog interface, we would be limited to the resolution of our analog signal, the quality of the conversion, both on the sensor end as well as the PLC end. Whereas with IO-Link, we have digital messaging going on between the master and the sensor, and then ultimately ending up in the PLC, that can basically give us exactly the information that we're looking for. So if the sensor is reading exactly 14.3 millimeters, we're going to get 14.3 back at the PLC without any analog to digital conversion required. Okay, let's talk about field replacement. Again, maybe it's going to take us, quite a few, maybe a couple hours to set up our sensor just the way we want, or maybe even longer than that. Well, if we have a traditional I/O interface, all the configuration is done completely separately, and then every time we have to replace a sensor, we've got to, go through that same process again. Whereas with IO-Link, if we've stored the sensor's configuration in the IO-Link master, all we have to do is plug in a off-the-shelf factory sensor, and then at power up, the IO-Link master will automatically configure it the way we need it. So we can be up and running in a matter of minutes, which is a very large advantage. Okay, let's also talk about the adaptability of IO-Link devices. So traditionally, if you need a specialized sensor, you need to very carefully build the part number through some sort of boxcar scheme for that specific one that you need, the specific sensor that you need. And then you need to order that specific part number, and it needs to be built. Now, with IO-Link, a lot of those customizations can be done in the field. So you can do it through programming. So you might be able to order just an off-the-shelf IO-Link sensor, make all the adjustments in the field, and get your sensor much quicker than you would if you needed to order something custom. So that adaptability is another big improvement or big advantage of IO-Link. All right, so as a wrap up to this quick video, IO-Link is a new standard for communicating with sensors and actuators. It communicates through messaging, not just through simple on-off or analog signals. IO-Link is not a Fieldbus, and IO-Link does not need special cabling. It just uses standard sensor and actuator cables up to 20 meters long. Now you're going to need an IO-Link master to act as the gateway between your IO-Link devices and the PLC or Fieldbus interface. And you're going to need software to configure your IO-Link devices. Now, a big advantage of IO-Link is that the master can store the configuration for each of its devices that it's connected to. So if you have to replace a device in the future, the master can reprogram the device instantaneously. A big advantage. Now, I did want to mention the fact that Horner does offer IO-Link devices. We have partnered with Banner Engineering for that. We offer a 2-channel or a 4-channel master, and these interface with Horner controllers through our MJ2 Modbus port. We also, in addition to the masters themselves, we have cables and programming kits available, and the software that's used to configure these devices is all just the standard IO-Link software from Banner. Okay, now I want to remind you, especially for those of you who are new, that we are here every Tuesday at 2 o'clock on YouTube, where you can watch live, or of course, you can always watch the replays on the Horner APG YouTube channel. In 2023, we celebrated 10 years of the Horner Lighting Group, so you can check out their great videos on the Horner website or the Horner YouTube channel right alongside our great automation content. We have great training available at Horner, and we've set our 2024 training schedule, which you can see there on the screen, but of course you can also not only see all the details, but sign up on our website. Now, the live streams for January will all be announced shortly, but we definitely have announced our live stream for next week, and that is setting the default I/O state for Horner I/O. So this is one of our Horner-specific live streams that for those of you who are familiar with Horner and who have used our products will find very useful. Now, if you haven't subscribed to our channel, don't hesitate to do so. It doesn't cost anything. And if you choose notifications when you subscribe, you'll be notified every time we go live or every time we post a new video. So until next week, let's all get out there and do us some good.